Mapreduce is an algorithm used to divide up big data jobs. The Mapreduce algorithm has been around for a long time. Although Hadoop did not invent Mapreduce, one of the core components in Hadoop is the Mapreduce engine and how it distributes work to nodes in a cluster. In this topic, you will learn the basic principles of Mapreduce and general mapping issues. You will also be able to describe the two steps in Mapreduce using mappers and reducers. In short, you will learn how Mapreduce is part of the Hadoop framework and how you use it to solve big data applications. In this example, we're going to go over the anatomy of a Mapreduce job and some programming considerations, and also a bit of history about Mapreduce and why it's so important. Now, what you see here is you see Eclipse opened up with a Mapreduce job within it. Now, Apache Mapreduce is Java-based, so you're going to have to know Java. If you don't know Java, you're going to have to learn Java to work with Mapreduce. If you don't know Java, there's some tools that we could use down the road to help, such as Pig and Hive, which are non-Java based tools for writing Mapreduce jobs. But here, let's look at some project settings. I'm going to go to Project Properties and show you the two jar files that you need to have in your path for this to work. So I have the Hadoop common jar and I have the Hadoop Mapreduce jar. These are the only two that you need to get started. Now, as far as Mapreduce goes, Hadoop did not invent Mapreduce. Mapreduce is a programming algorithm, a distributed programming algorithm that's been around for at least 10 years or so. And let's talk a little bit about what it does. Up until very recently being the year 2000 or so, there was always an exponential increase in processing speed and power of CPUs, where from the 80s to the 2000s, there seemed to be always an exponential growth in how fast computers got. So the way we process information really didn't change that much, because we would always assume that we would get an exponential leap in processing power with the new batch of processors that came out. Now, right around the year 2000 or so, there seemed to be some stagnation in how fast these chips can get. So people started looking at different ways that we could process data. So rather than assuming that CPUs are going to get faster and faster and faster, we started looking at the way we process data and said, well, maybe we should look more at distributing the process and the computation rather than having a CPU do it. And that's really the genesis of Mapreduce. Mapreduce has been around since approximately 2004, and as the saying goes, Hadoop did not invent Mapreduce, but it did make it famous. So what Mapreduce does is Mapreduce, here Apache Mapreduce, what it does is it takes the Mapreduce algorithm and distributes it across many different nodes in the cluster. Now, when you just start out, you might just be using a single node cluster, so you might ask yourself the real utility of this, if it's only running on a single node. And you're right that we're not actually distributing this across multiple nodes as you're learning it, but it does at least illustrate the basics and how the whole thing works. So let's go over the code. Again, it's a simple program, and there's really not a lot to it. We have our imports, and as you can see, we have some standard Java packages that we're importing. So we're going to need the Java IO package and the Java util package. And these imports here are from those two jar files that I showed you previously, where we're getting our Mapreduce classes and we're getting some of our core Hadoop classes. Now, as far as the code goes, Mapreduce programs are Java applications. So being a Java application, we're going to have a main method. So I'm going to navigate down to the main method. And as you can see, there's only really a few lines of code. When we're writing Mapreduce programs, most of the functionality that is implied, or most of the functionality that is executed, is hidden from us. Sort of like when we're doing anything with XML, where an XML parser might actually hide most of its implementation. Mapreduce works in the same way. The only thing that we're really concerned with, or the two main things that we're concerned with, is the mappers and the reducers. Now here what we're doing is in our main method, again our main method is our method where the job actually starts running, is we do a couple things, really just a couple things, where we set some job parameters, where we put here some information that has to do with our system configuration, and then we're setting some job parameters in these lines of code here. And then we're using the file input format to determine exactly the format of the data that is going into our mapper, and where the opposite is also true, where we're setting a file output format from our reducer. So as you can see, the code and actually getting this to run, as far as we're concerned, is not that large or not that vast. Now, going up to the top of the program, we really have two static classes. Where we have our static class that does the mapping, as you can see highlighted here. And anytime that we define a mapper, what we want to do is we want to extend the mapper class. And you can see we have our code for reading our key value pairs here. And then we have the code for our reducer. And when we build a reducer, we always extend the reducer class. That's pretty much it as far as what's exposed to the developer, where we have our main method, we have our map section, and our reduce section. Now again, if you're running this on a single node cluster, this is still a very good illustration on how Mapreduce works. Now deploying this and actually building this Mapreduce program and jarring it up and installing it is a much more complicated task, and it's a lot more difficult than just to run this as a regular Java application. So actually jarring this up and deploying it is a whole different task than actually programming a Mapreduce job.